All right, hello, integrated Math 1 students. Today's lesson is on solving equation objectives. Students will be able to solve one and multi-step equations. Students will also be able to complete tables given to variables and a rule. So let's chat about this. First off, we want to know what an equation is. So an equation is a statement that the values of two mathematical expressions are equal, okay? So even if I just said that, hey, you know what? 5 is equal to 5, that's an equation because we have two things that are equal. Simple. Couple things that I want you to know about solving an equation. When I say solve, students often think that that means that you're actually going to get a value for every answer, and usually you do. Usually you end up with something like x equals 3, and that's solved. But that's not necessarily what it means. For example, I'm going to zoom in so I have plenty of space here. Let's say I was to have this equation where I have x plus y equals 3. I can still solve for x even though I don't know what y is. Here's what I do. I subtract y, because when you're solving, you're undoing what's happening to the equation to get one of the variables all by itself. So I could subtract y from both sides, and these would cancel, and then I would have x equals 3 minus y. Technically speaking, this equation is solved for x because x is all by itself. So when we say solve, what do we really mean? Solve means that you isolated a variable. Just want you to understand that. Now, for the most part, we will have an actual number here. We'll say, yeah, x equals such and such. But it doesn't always have to be the case. We can solve even with another variable in there. All right, then we have this list of inverse operations. Why is this important? Well, because remember, what we're going to be doing is we're going to be undoing what's happening to our variable that we're trying to solve for it. In order to isolate the variable, we have to undo what's happening. So if something's being added to it, we subtract. If something's being subtracted, we add. If something's multiplying, we divide. If something's dividing, we multiply. And if there's an exponent, usually an exponent of 2, we would take the square root, because if I was to say like 5 squared, the opposite action would be that you take 25, which is 5 squared, and you take the square root, right? So these are opposite actions. We'll put that into practice here with a few examples. So let's start off with example number 1. 3x equals 9. The question I want you to ask yourself regularly, and you might hear me say it a few times in this video, but the question I want you always asking yourself is, what is happening to the variable? And when I say the variable, I mean the variable that you're solving for. So in this case, I have 3 times x equals 9. What's happening to the variable? It's being multiplied by 3. All right, I don't want it to be multiplied by 3. I want to undo that. So the way we undo multiplication is with division. So I'm going to divide both sides by 3. Simple enough. These cancel each other out. And now I have x equals 9 divided by 3, which is 3. And voila, look at that. We got the answer, x equals 3. Let's take a look at example 2. Right here I have 1.6 plus x equals 10. What's happening to the variable? Well, it's getting this 1.6 added to it. I don't want that, so I want to undo that. So I'm going to subtract 1.6. And I have to do it to both sides. Whatever you do to one side, you have to do both. The reason for that, I'll just take a little side note. The reason for that is, remember, we're saying that this thing over here is equal to 10. So this is 10. Well, if I was to take away a value from here, it would no longer be 10, and so it would no longer be equal to the 10 on this side. So we want it to stay equal. Like, imagine if I started with the equation 1 equals 1, and I added 1 to it, I'd get 2 over here. And if I didn't add to the other side, I have 2 equals 1, and that's no longer true. So that's why what we have to do is we have to add it to both sides, and then we still have a true equation. Okay. Whatever you do to one side, you have to do the equal operation to the other side. So these cancel each other out, and I'm left with x equals 10 minus 1.6, which is 8.4. All right, let's check out example number. Actually, it's practice problem time. All right, so what I want you to do is I want you to try these 2 practice problems on your own. You're going to pause the video, work it out, and then unpause when you're ready to check your work. Okay, let's talk about these 2 problems. First off, I hope you recognized over here C is being divided by 4.6. So that means if it's being divided by 4.6, you want to multiply both sides by 4.6. So I did that, multiply both sides by 4.6. These would cancel out. So you're left with C equals 5 times 4.6, which is 23. Over here, this one's a little bit more interesting. If you think about this, you could say that V is being multiplied by 1/5. And so you could divide both sides by 1/5. However, something I want you to know, maybe you want to write this as a little rule here. Dividing by a fraction is equal to multiplying by its reciprocal. This is a rule in math that's very, very useful. What do I mean by that? Well, let's say I had x divided by 1/2. That is the same thing as saying x times 2, because the reciprocal of 1/2 is 2. You literally just flip it. And yeah, you could think of this as 2 over 1, but we don't really do that when there's just a 1 on the bottom. We just make it just 2. So that's the rule. In algebra language, we would write it like this. A divided by the fraction of 1 over b is the same thing as a times b. Okay, so that's why in this case I divided both sides by 1/5, but really that's the same thing as multiplying both sides by 5. So here I divided, here I multiplied. I could have also just multiplied both sides by 5. It's all the exact same thing. So the answer is 30 times 5, which is 150. All right, let's get going here. What I want to do on this one is I'm going to do one, and then you're going to do the even one. So I'll do the odd, you do the even, odd, even, and so on and so on. So let's zoom in on number 1. Let's take a look. Now we have multiple terms, multiple variables, and we have to get the variables all on one side. Here's what I do. I just pick a side to put the variable on. It doesn't matter which side. Usually for me, if one is bigger than the other or more positive than the other, I'll just let the bigger one or the more positive one be the side that it stays on. So since 7 is bigger than 6, I'm going to choose this side to be where I put my variables, which means I want to get rid of this one. I want to move this to the other side. So I want to get all the variables on one side, and I want to get all the constants on the other side. So I'm going to start by saying, you know what I need to do? I need to subtract 6r from both sides. And I'm just going to write it right underneath the r term. And this part is up to you, but you're also allowed to adjust the constants at the exact same time. So since I'm moving this 6 over here by subtracting from both sides, I need to get rid of this 13. I'm going to get rid of this 13 by subtracting 13 from both sides. So these will cancel and these will cancel. Now I just have two simple operations. 7 minus 13 is 6. Actually, it's negative 6. And then 7r minus 6r is simply 1r. And you don't need to put the 1 there, right? And boom, I'm done. R equals negative 6. All there is to it. So that's how I like to do it. You don't have to do it that way. I could have subtracted 7r. But if I would have done that, let me just show you. If I would have done 6r plus 7 equals 13 plus 7r, and I would have done it the opposite way. I would have subtracted 7r, I would have subtracted 7r, and then I would have had to subtract 7 and subtract 7. What would I get? Well, I'd have 6r minus 7r, which gives me negative r. These would cancel, equals 13 minus 7, which is 6, and then these would cancel. I would give myself one more step to do because this is not isolated. This is not solved for r yet because it has this negative symbol out there. So what would I have to do? I'd have to multiply both sides by negative 1. And then the negative times the negative would make positive r, and then 6 times negative 1 would make negative 6, and then I would solve it. There's nothing wrong with that. It's totally mathematically sound and good. I just like to have as few steps as possible. So that's why I want to have the more positive number. That's the side I go to. Okay, I want you to try number 2 on your own. And remember, pause the video and then unpause it when you're ready to check your work. Okay, I decided to move the x's over here because, see, this is closer to being positive than this one, so it's bigger technically. So I added 4x to both sides, got positive 3x. I subtracted 1 from both sides, got positive 12. And now I have 12 equals 3x. What's happening to my variable? It's being multiplied by 3. Therefore, I need to divide both sides by 3. These would cancel. 12 divided by 3 is 4. And there's my answer. X equals 4. Hopefully you're seeing how this works. Catching on. Uh-oh, there's a whole bunch of terms with an x in it. No big deal. Here's what we're going to do. First thing is, I'm just going to combine like terms. Get it a little bit simpler. Now, which one's more positive? Well, this one's bigger technically. I know 10 is bigger than 8, but if you're thinking about a number line, negative 8 is actually bigger. So we are going to add 10x to both sides. And at the same time, I'm going to get rid of this negative 8 by adding 8 to both sides. These cancel, these cancel. What do I have? I get a 10 equals 2x. What's happening to my x? It's being multiplied by 2. So I need to divide both sides by 2, and I end up with x equals 5. I like to put the variable first. You don't have to. Just a preference thing. You could just as well say 5 equals x. That would be just as true. All right, you guys are going to try number 4 on your own. Remember, combine those like terms first. And then, so pause the video and then unpause it when you're ready to check your work. Okay, on this one, I kind of broke my own rule, and I'll explain why. Let's start off with combining like terms. This is really 1x minus 4x, which makes negative 3x. And then, really, this would be the bigger term, so I could add 3x over here. But then, I'd have to add the 8 to the other side. So since I only have variables over here, I went ahead and decided to make this my variable side. Just a preference. I could have added 3x and then added 8. But I rather just make this my variable side. So I added x, that became negative 2x. And then these canceled out, so I got negative 8 equals negative 2x. Then I'm just going to divide both sides by negative 2. And a negative divided by a negative is a positive. So there's that page. Let's go on to the next page. All right, so what do we do when we have parentheses? You have a couple options, but I'm going to teach you to distribute first. There's a way to do it without distributing first, which, you know what, I'll try to show you both. I'll do 5 and 7 right now, and I'll show you both ways. And then I let you decide which one works best. But it gets tricky if you don't distribute first. So that's why I just recommend that you always just distribute first. So let's do it without distributing on this first one. Without distributing. And what we're going to do is we're going to just try to get rid of this negative 8n. We're going to work our way in. So the first thing I'm going to do is I'm going to add 8n to both sides. And that will cancel this out. And I have a new equation that says 4 parentheses 1 plus 5n equals 2n minus 14. So what you can do, but you'll see why it gets complicated, is you could divide both sides by this 4. So you have a 4 out here, and you don't want it. You want to get rid of that thing out there so that you could just attack what's on the inside of these parentheses. So we could divide both sides by 4. No big deal. These 4's cancel out. Beautiful. So on the left, I'm going to have 1 plus 5n equals, how do I do this? Not as bad as you think, really. Really, you're just going to divide each of these by 4. So really, you have like 2 divided by 4. Well, that's the same thing as 1/2. Just a little side note, right? If I had 2 over 4, that'd make 1/2. So what you're allowed to do here is you're allowed to say, well, that's 1/2 n minus 14 divided by 4. You could, another little thing, you could just think of this as reducing fractions. You could take a 2 out of both of these, make it 7 over 2. So we're going to say minus 7 over 2. And maybe right now you're seeing the problem with this, right? Now you have a bunch of fractions in your work, which is not a huge deal. You can still work with fractions. They're numbers. But it might make it a little bit harder is all I'm trying to say. So let's keep up with what we were doing, though. Now I have a 5n and a 1/2 n and a negative 7/2 and a positive 1. Remember, I said we got to get all the variables on one side, and I usually want to go to the bigger variable side, which would be 5n. So what do I have to do? I need to subtract a 1/2 n from both sides. And then I'm going to subtract a 1 and subtract a 1. And this is getting a little messy or a little crowded, so I'm going to come over here. These will cancel, and these will cancel. So let's talk about what I have. I have 5 minus a half. Well, if you have $5 and you take away a half a dollar, you're going to have $4.50 or 4.5. So I'm just going to write it as 4.5 for now, n. And then I have negative 7 halves minus a 1. All right, so this might take a little bit more thinking. So let's do this off on the side here. Negative 7 halves minus 1. Well, remember, in order to add or subtract fractions, you need common denominators. So I'm going to think of this as negative 7 halves minus 2 over 2. So I have common denominators. Anytime you're taking a 1 and getting it to make a fraction, it's literally just whatever number you want on bottom over itself. So here I wanted a 2 on bottom, so I'm just making it 2 over 2. Well, negative 7 minus 2 makes negative 9, and that's negative 9 over 2. So over here, I could say this equals negative 9 halves. But since I did decimals, it might be a good idea to just go ahead and convert this to a decimal. The easy way to do that is just do 9 divided by 2 in a calculator. Then you get a decimal, or you could do a long division real quick. But either way, you're going to get 4.5 here, or negative 4.5. So I get negative 4.5. All right, last step here, I have what's happening to my variable. It's being multiplied by 4.5, so I need to divide both sides by 4.5. These cancel, and I'm left with n equals negative 4.5 divided by 4.5. Anything divided by itself is just 1, but there's a negative here. There's a negative also, so we're going to call this negative 1. So that should be my answer. Okay, if you found that process kind of confusing, I don't blame you. There's a lot going on. Fractions got involved. It got just messy really fast. So that was, remember, that was without distribution, okay? Well, what I want to do is I want to do with distribution now. So let's try with distribution. And I'm not writing out the whole word, but with distribution, what would that look like? And I think you might prefer this method. Okay? There's nothing mathematically wrong with what I did up here. It's just a lot of work. So let's see if we can make it easier on ourselves. So what I recommend that we do here is the first thing we do is we distribute this 7. And we get a new equation that says 4n minus 40 equals negative 14n plus 14. And look, no fractions. Usually when we distribute, as long as there weren't any fractions to begin with, we won't have any fractions. But you could see if I tried to divide 40 by 7 or 4 by 7, I'd get some fractions, and it might get messy really fast. So I like to avoid that. It's not that fractions scare me. It's just going to be a little bit more work. All right. What can I do? I want to get all the n's on the same sides. I have a 4n and a negative 14n. This is technically bigger because it's positive. So let's go ahead and do that. Let's add 14n to both sides. While I'm doing that, I can add 40 to both sides. So these cancel, these cancel. What do I get? 4n plus 14. N makes 18n. And 14 plus 40 makes 54. Now I'm going to say what's happening to my variable. It's being multiplied by 18, so I need to divide both sides by 18. Boom, boom. Now, 54 divided by 18 happens to be 3. So n equals 3. Very cool. All right. I think most of you will probably prefer the with distribution way, but hey, if you're a math geek like me, maybe you want to try it without distributing. So what I want you to do right now is go ahead and try number 6 and 8 on your own. Remember, pause the video, then just unpause it when you're ready to check your work. Okay, here's my work for both 6 and 8. For number 6, I got the answer n equals 3. For 8, I got a equals 1. Just recap briefly. I distributed. On both of these, I distributed. I think it's easier. Then I combined like terms. Then I saw that negative 6n is bigger than negative 14, so I added 14n to both sides, added 20 to both sides. And then you're down here with 8n equals 24, so you need to, it's being multiplied, so you need to divide both sides by 8. Same idea here, distribute the 7. I get this equation, combine like terms to get negative 29. I want to move to this side because that's bigger. I add 8a to both sides. I add 29 to both sides. I get 43a equals 43. Well, divide both sides by 43 and you get a equals 1. 43 divided by 43 is just 1. All right, let's keep going. What if we have decimals? No big deal. We can deal with decimals. Really, decimals is just like any other number, but you're just like have an extra place. That's all it is. So let's go ahead and start off by distributing this 5. So I'm going to rewrite the new equation below. It'd be 6.5 minus 5 plus 35f equals negative 21.5. All right, these are like terms because they're both constants. So 6.5 minus 1.5 becomes, 6.5 minus 5 becomes 1.5. See, I'm thinking about the answer as I am doing the problem. Plus 35f equals negative 21.5. Now I'm going to subtract the 1.5 from both sides. And I get 35f equals negative 21.5 and negative 1.5. It's like digging a hole 21.5 feet deep and then digging another 1.5 feet. So it's kind of like adding these together, essentially what's happening here. And so you're going to end up with negative 23. Lastly, what's happening to my f? It's being multiplied by 35, so I need to divide both sides by 35. And so you get f equals negative 23 over 35. And that's actually just fine to just leave your answer as a fraction. If you want a decimal, you could plug in a calculator, do negative 23 divided by 35 and get the decimal answer. But that's just fine. Okay. Let's do 11 as well. So we're going to always start off and seeing if there's any like terms that we can combine, and there are. We can combine these two like terms. So I have 3.5a, 9.5 minus 8.5 is just 1. So I'm just going to say plus 1 equals 26.5. I'm going to subtract 1. So now I have 3.5a equals 25.5. What's happening to my variable? It's being multiplied. So I'm going to divide both sides by 3.5. Now, we get this weird thing. We don't usually want decimals inside of a fraction. It's weird. And if you were to actually divide this out, you're going to get a very random decimal. It's not going to be nice and pretty. So I want to explain something that we can do here in certain circumstances. If you were to think about what this would look like as a mixed number, it's 25.5. So really, it's like saying 25 and 1/2. And on the bottom, it's like saying 3 1/2. This might seem a little strange, but you have a 2 on the bottom, basically, for both of these expressions. Remember, if you were dividing by a number and you wanted to cancel that out, you could just multiply by its reciprocal. Well, essentially what I can do here is I can multiply both of these, the top and the bottom, by 2, and it's going to give me a prettier fraction. If I was to multiply the top by 2 and the bottom by 2, what would I get? Well, I'd get 25.5 times 2 is actually 51, and 3.5 times 2 is 7. And now I have a prettier fraction. Yes, it's improper, but that's okay. Unless the directions say, like, change it to a mixed number or something, we can totally leave it as an improper fraction. Not a big deal. So I think that looks a lot cleaner than that. And so that's what I want to do. Again, I could just plug this into a calculator and get a decimal answer, but it's going to be weird. You're going to have to round. So this is a cleaner, more exact version of the answer. All right, so I just did 9 and 11. I want you to try and do 10 and 12. Again, pause the video and then unpause it when you're ready to check your work. All right, so I have these like terms here. You might get confused because there's a minus sign here, but there's no parentheses. So that minus only applies to the 8. It does not apply to the 5.5. It's positive. So when you add those together, you get 10h minus 8 equals negative 29.5. Add the 8 to both sides. You get 10h equals negative 21.5. You got to divide both sides by 10 because you're multiplying by 10. But dividing by 10 is really easy. All you're really doing is you're just going to move the decimal over to the left for every number of zeros you're dividing by. So if I was dividing by 100, 100, I'd move it over 2 spots, 1,000, 3 spots, and so on. So this is really easy to figure out without a calculator. All you got to do is just move that decimal over 1 spot, and you get negative 2.15. And then on number 12, very similar to number 11, we do have some like terms. You get 1.5s, so then you have to divide both sides by 1.5, and then we have this weird fraction, like decimals inside a fraction. We don't want that, so we know this is really just like saying 1/2 or 1/2. So we're gonna multiply top and bottom by 2. By the way, the reason we're allowed to do that is multiplying by 2 over 2 doesn't change its value, because if you think about it, 2 divided by 2 is just 1. So all we're really doing is multiplying it by 1. So it's not changing its value, it's changing the way it looks. And that's why we're allowed to do that. So when I do that, I get negative 41 on top, 3 on bottom, improper fraction, and that is just fine. All right. Let's do these last two. What I want you to recognize here, on both of these, we have a variable on top of a fraction, and it might seem scary, but it's actually pretty simple to think about. Remember, you're always working from the outside in. You're trying to undo the order of operations. So yeah, k has a 12 being added to it, but that doesn't really matter right now because outside of that, it's also being divided by 29. And when you're solving, you need to go from the outside in. It's like the reverse order of operations. Because you're undoing the math, that's why you're going to go in the opposite order when you're solving. Another way to think about it is anytime you have like a fraction like this, you could think that there's like invisible parentheses there. So you could go ahead and think that there's invisible parentheses here and there. On this one, though, I think I'm actually going to do, on this one, yeah, I'm going to do 13 and 14, and you guys are going to do 15 and 16. So let's do 13 first. I need to get rid of this 29. I don't want this fraction here. I don't want it there. This whole thing is being divided by 29. So what I can do is I can just multiply both sides by 29. And that's going to let these 29s just cancel out. So now I have k plus 12 equals negative 6 times 29. Which, don't worry, I had to go to my calculator too. That's negative 174. I'm sure you could work it out, but if you have a calculator handy, this is what it's useful for. And then I'm going to subtract 12 from both sides. And I get k equals negative 186. Boom. That was easy. All right, that's 13. Let's take a look at 14 real quick. All right, I already only have one variable. I have a constant and a constant, so I want to get rid of this constant. I want to move it to the other side. To move it to the other side, I have to undo what it's doing to my variable, and it is adding 25. I know your instinct might be to get rid of this 1/7, and it's possible to deal with this first, but remember, we want to go from the outside in. So order of operations normally say multiply, then add. So when we're solving, we go backwards. So we are going to subtract 25 first. So that leaves me with 1/7 times n equals negative 54. Remember, I could divide both sides by 1/7. But remember, that's the same thing as multiplying both sides by positive 7. It's the exact same thing. The reason why that is, let's back up. Let's show you how we could do this. If I was to multiply this by 7, that's like saying 7 over 1. And then your 7s would cancel, and your 1s would cancel, as long as you multiply this side by 7 too. So that's why we can do that. We can just multiply by a 7 instead. So you get n equals negative 54 times 7, which is negative 378. And boom, you're done. All right. You're going to work on 15 and 16. Pause video and then unpause it when you're ready to check your work. All right, so I had to multiply both sides by negative 26 because it's being divided by negative 26. Then I got here, and so I needed to add 28 to both sides, and I got x equals 106. Over here, I needed to get rid of this 8, so I subtracted it from both sides. Then I have 1/8 s equals negative 11. Remember, I can just multiply by the reciprocal to get rid of a fraction, so 8 times 1/8 just becomes 1s. And over here, negative 11 times 8 is negative 88. All right, that's the end of this video. I want you guys to think about this problem on your own. If you can't figure it out, remind me to talk about it in class. See you guys on the next video.